This is James Peyer, and you're listening to the Matt Balaker podcast.
Good day, folks. Thank you for tuning into the Matt Balaker podcast. Please do me a favor and click subscribe. And if you want to share it with at least 7 to 48 of your closest friends, that's cool with me. I love you guys. And as an expression of that, I bring on the best guests I can find. And today's one is fantastic. He's the founder and CEO of Cambrian, a company focused on extending lifespan people. Before that, he launched Apollo Ventures, a company builder for longevity therapeutics. He earned his PhD in stem cell therapy, and he has amazing hair. Please welcome James Peyer to the program. How are you doing, James?
I'm doing well. Thanks for having me on, Matt.
Well, I'm excited to have you on. I understand you did your undergraduate work at the University of Chicago. So most importantly, James, if people are spending a day or two in that great city, and they're looking for something to eat, what would you suggest?
So I grew up around Chicago. My parents grew up and actually met in Chicago. So it's been like the big city my whole life. And there's a Chicago institution that's been around for more than 50 years called Oven Grinder.
Grinder.
It's got like a more complex name. It's like the original Chicago oven grinder or something like this. But if you go and you look for an oven grinder, it's like they serve really one thing. It's called a pizza pot pie. And so imagine a Chicago style pizza, but taken up one more notch. And it's really a true Chicago experience.
So we need a thicker crust, more butter. Like realistically, James, how much could a normal person consume at this place? Like a full slice, half a slice? What say you?
So an oven grinder, you don't even slice it. It really is like a pot pie. So it's delivered, and it's probably like 1,800 calories of tomatoes and cheese and they bake like whole mushrooms into the sauce, and it's got a crust cover on it like a pie, but it's a pizza on the inside.
Oh, I can feel my cholesterol boiling, but that sounds delicious. So yeah, so someone who's dedicated his career to longevity, how do you balance that? I mean, obviously, like we can't just eat quinoa all day. I mean, like, what's your philosophy on eating for pleasure versus longevity?
So I think one of the big takeaways of anyone who's studying both what I do, which is like the molecular biology of aging, but I think really the practical applications of it are people who study nutrition science and exercise science and these sorts of things, is that the real takeaways are that we like the difference, if you apply the Pareto principle, right? 80-20, right? 80-20 is such a big driver of what's going on in health, that you can do things, if you steer towards a healthy diet and a healthy exercise regimen, you're getting most of the way to your best fitness. And then that additional 20% requires an additional, requires 4x the effort of getting to that 80%. And so I like to think of myself as maybe not going 80-20, but I like to go 85-15, something like that. And that means, it's okay to have a glass of wine once in a while. I'll still, have some dessert once in a while. I'll have a pizza pot pie if I'm going through Chicago. But overall, my nutrition advice to myself and others is don't get diabetes. And if you do not get diabetes, then you are better off than most adults in our modern world.
That's a good point. And you hear that, audience? Don't get diabetes. It'll help extend your life and give you a more enjoyable life, most likely. And so you mentioned you grew up in Chicago, really cool place. When did you know that you kind of had this bug or this penchant for science?
Well, so as a kid, I was getting really interested actually in space. That was kind of my first scientific love. Like many folks of our generation.
You're going to be an astronaut. Yeah.
Exactly. Right. I grew up with Star Wars and Star Trek and like wanted to be an astronaut and all of this. And And as I started reading in my teens, started reading more kind of like hardcore science fiction, like Isaac Asimov and those sorts of folks, Robert Heinlein and these types, I was like, oh, you know what the thing that I would find most interesting as like a human experiencing the vast cosmos is like that moment where we move into living in extraplanetary as an extraplanetary species, right? Like whether it's an orbiting space colony or a moon base or whatever it is. And as I was romanticizing that to myself, I was like, when will this realistically happen?
Hmm.
And the more I read and the more I looked into it, I was like, I will probably be too old to really be on the cutting edge of this by the time that it's going to happen, right? Even if it happens, it's going to be late in my, you know,
Hmm.
fourscore years or whatever that I'm allowed to be on the planet. And that felt like a shame. So the optimistic story of how I got into this particular realm of aging science is it just felt like this was such a short time to be given a window to experience the universe. And and if there was any way, could I like think about for myself and for others expanding that window to see more of what the universe has to offer us? And that felt like such a philosophically rewarding and like universally good concept that it's been since I was a teenager, this like mission that has propelled my life forward.
Wow. So at a time when I was asking my mom to cut the crusts off a PB&J sandwich, you're contemplating your place in the universe and how to maximize your time here. And I'm inspired. Obviously you're a precocious young kid. You like science fiction. What were you like as a student though? Like before college, were you the smart kid? Were you the quiet kid in the back? Share with us.
So so I was a little bit of a I describe myself as a bit of a jack of all trades. I was not the valedictorian of my class, but I was like, a step or two beneath where I was taking all of the
Valedictorian
advanced.
adjacent. Yeah. Okay.
Yeah, exactly, right? Um, so I was mostly getting good grades, but I think where I was good was I was at like if not first, second best in almost every subject,
Okay.
right? And so I loved literature and writing and math and science, like biology, physics, chemistry. I was never much of a linguist, but I was also, on the sports teams and Quiz Bowl and these I had a couple of sort of business interests and was getting kind of excited about entrepreneurship and these sorts of things. And that roundedness kind of shaped where I moved from the high school into sort of university and beyond transition.
Yeah, I mean, for someone like multifaceted like yourself, University of Chicago seems like a great place. Like I know it mostly for like Milton Friedman and the econ department,
Yeah.
but it's very cross-disciplinary. Like it, I guess share with us what you liked about University of
Yeah.
Chicago.
So it's interesting. My path to U Chicago was shaped by two dramatic misunderstandings. Uh, the first one was that I applied to a few different programs, and one of the other ones I was considering was an accelerated BS plus MD program, so like a 6-year program that would give me an undergraduate and a medical degree.
Hmm.
And and I said, okay, well, actually, I don't want to do that. I want to do more undergraduate science and have like a well-rounded, like a liberal education, and
Hmm.
spend the full 4 years as an undergrad. And so that's why I pivoted into U Chicago, which is famous for building like a great books themed undergraduate curriculum. And then it turns out I got there and I actually didn't like those classes that much. And I ended up spending my last 2 years at U Chicago taking only the graduate school courses for first immunology and then cancer biology. So completed the two grad programs for um, basically two different master's degrees in bio, and then went to my PhD instead. And then the second sort of misunderstanding is that I was um, being recruited to play Division I soccer by another
Cool.
school, and decided that I didn't want to spend my time in college playing varsity sports if I was going to be a scientist. And so I thought that University of Chicago had no varsity athletics because they got rid of their famously, right, the first particle accelerator was built underneath the U Chicago football stadium. And then when they realized that the football stadium couldn't exist over the particle accelerator, they got rid of the stadium instead of the particle accelerator. And I'm like, this is a school that has its priorities straight. And so then I got there and realized they actually do have a varsity sports program. But in any case, those were the stories that kind of got me in that direction. It worked out all right.
It worked out all right. So you finish undergraduate, and then what did you do after that, James?
So the big decision for me was whether I wanted to go into an MD or a PhD, or you could do both, right? You can do an 8-year MD plus PhD program if you want to go into science. When I started undergrad, I was like, oh, well, this is great. I'll do undergraduate research, learn all I need to do to be a scientist there, and then I'll go get an MD so I can understand treating patients and this kind of stuff. And then I'll go do drug development after that, ABC. And by the end of 4 years of undergrad, I realized that this whole aging biology science thing was actually a little bit more complicated than my 21-year-old brain could absorb. And I needed to spend a lot more time really understanding how to make discoveries and learn stuff in science. And that pivoted me hard into I need to do a PhD in basic science to keep drilling into this. Then the question was just like, what topic do you focus on, and how do you find a mentor, which led me to a guy named Sean Morrison at the University of Michigan, who was the most careful and kind of critical stem cell biologist that I had ever encountered. And he just cared so much about every single thing that came out of his lab being right. And that, and that if other scientists did anything that was like overstepping or overinterpreting their data, he would be ready to pounce on them. And I was like, that's the type of education that I think is the best to get as a grounding for science. And so I kind of gravitated towards his lab and spent 6 years there.
Wow, that's really interesting. And I want to kind of unpack an important point you mentioned. It sounded like your mentor was very critical of the approach you took to science. And I want to get in a lay perspective, like we've had some scientists on the show, and this topic interests me. Like, what is science, in your opinion, very good at, and in what cases can it be overanalyzed or taken to a way where you think it's beyond the scope of what the intended purpose is?
Yeah. So I want to distinguish between two different types of science in answering that question. I'm going to call them, broadly speaking, let's call it academic science, and then pharmaceutical drug development or something like that, which are sort of the two worlds that I've played in my career, right? And as an academic, right, so you've sort of a finance background, or like, and in the economics world, we always look at things in terms of incentives. And so I prefer to look at these two worlds in terms of what the incentives are. And as an academic scientist, your success is primarily determined by the papers that you publish in peer-reviewed scientific journals. So if you think about what the incentive hook there, it's kind of like that peer recognition. Like, we could distill it into a single word. It's like fame. Right. And in order to get
clout, for
clout,
social media influencers out there, it's clout.
Right. And what that's really, really good at creating incentives for is taking bold, novel ideas, trying new things, making new fundamental discoveries that end up being maybe important, maybe not important, but like change the way that we look at the world, either at a macro or more often at a micro scale. And I think that's where academic scientist has been wonderful. And the stuff that I work on now in aging biology has been driven by a bunch of these intuitive leaps taken by really creative risk takers on that academic science side. But the thing that is the big limitation of academic science is to get at, whether something is true is not always the same level of incentives. And so there's a very famous paper where a big biotech company called Amgen took, I think it was like 80 different academic studies that proposed to have created new treatments for cancer that eliminated cancer in mice. And they just tried to recreate those experiments. And out of, again, my numbers might be slightly off here, but out of roughly 80 that they did, only about 10-15% they were even able to recreate the same results that the academics saw, right? A
Wow.
tiny fraction. And we saw this in stem cell biology world as well, that even, academic lab to academic lab, we couldn't repeat something that another lab did. So either it was something unique about how they were handling the things, or it at least wasn't as generalizable and easy as it looked in the paper that was published. And then again, I know this is turned into a long tirade, but on that second side of like thinking about what sort of the business of biotech, what that incentive structure is around, thanks to the fact that everything that we do has to go through clinical trials and has to show safety and efficacy and so on, the incentive there is much more driven by truth, right?
Mm.
Is actual, like, have you made a drug that will positively affect people? And so the incentives are actually much better structured there to be really careful about whether your drug has the effects that you think it has. And so figuring out how to cherry pick stuff from the really creative and innovative academic discipline and then put it through the ringer of, is it true and is it really going to impact biology the way we think it is on the drug development side? That is a really interesting dance that I've spent my whole adult life kind of trying to figure out.
Well, you're the belle of the ball at this dance, I must say, because it's rare, in my opinion, to find people who are kind of trained academically at a young age to then think commercially, because you're
Mm.
generally mentored by people who are in academics, and so your worldview is pretty limited. But you kind of escaped the academic lab, so to speak, and you launched Apollo Ventures. That's pretty ambitious, and you were young when you did that. What motivated you to do that, James?
So we already talked a little bit about how I decided that I was going to work on aging when I was
Mm-hmm.
pretty early on, right? Like when I was a teenager. And and I was interested in not just making discoveries, but making medicines from that point, right? Like just making a discovery I knew would not be enough. We would have to be able to make a medicine out of it. And so I got this idea into my head from an early age that however successful I was academically, I was going to have to learn something about starting biotech companies.
Right.
So I actually decided that the best way to learn was to do something, um, and started a biotech company actually when I was still an undergrad, when I was 21. And so my first company, I didn't know anything about drug development at that stage,
Mm-hmm.
but I knew something about high school biotech education and how crappy it was. So I started a science education company when I was an undergrad that would teach high schoolers how to do genetic engineering. And I actually kind of caught on. We were actually one of the first biotech company, I think the first biotech to raise money through Kickstarter in the super early days of Kickstarter, and and then it got to the point where I was sending these educational kits to schools in about half the states, and we had some collaborations with universities. I didn't know what venture capital money was back then, so I was cleaning glassware in my lab and like running basic experiments and then buying the machines on eBay, like leftover lab machines on eBay to build all these things. And so we kind of bootstrapped it with the cash that I had left over from my undergrad job. And it was going all right. And that was kind of my first brush with sort of this entrepreneurial
Mm-hmm.
idea. Um, and so that allowed me, as my grad school kind of then progressed over the next 6 or 7 years, and I saw discoveries in aging biology being made left and right, right? We were discovering these new, whether it's a gene or a new drug that extends the healthy lifespan of a mouse.
Mm-hmm.
What I saw is that my colleagues would be making these discoveries, but then they wouldn't be turned into a biotech company. And so I got obsessed with the question of why not? What was missing? Um, and and that brought me first, again, because I didn't know the answer to that question, but I was like, there has to be some answer about how you develop drugs that's missing in these scientists that have made these discoveries, and presumably also in the pharma companies or VCs that they're talking to who are declining to fund them. And so I first ended up after my PhD at a consulting firm. I went to McKinsey's pharmaceutical consulting division.
It's for those in the audience who are unfamiliar, probably the biggest consulting firm in the world, maybe most prestigious, if not number one, right up there. But please
Yeah,
continue.
yeah, up there. But it was pretty cool because I got to go from being an academic scientist, and then, in the over the course of like a month, I went from, running mouse experiments on, on these very, very narrow topics to talking to these 30-year pharmaceutical executives who were like, we need to deploy $5 billion into cancer research this year. James, we're really interested in your opinion on where we should do that. And that really changed my frame of reference and thinking about how this bigger world of funding and advancing science worked, and how that connected back to the bench science that I had spent my career doing.
Mm-hmm.
Um, and I started kind of, again, without trying to let this run on too long, but I started getting fascinated by how little biotechs sort of budded out from discoveries in the lab, and what made those biotechs interesting and ultimately successful. And I started developing a mental pattern or a mental awareness of like what good looked like for
Mm-hmm.
those little biotechs, because I got to look at them from the perspective of the pharma companies that wanted to buy them a few years down the road. And I saw all of those features of what makes a good biotech missing from these little startups that were thinking about or were kind of stillborn in the aging space. And I was like, well, what if we could start applying a more productive biotech, successful biotech-like framework to all of this aging science?
Mm-hmm.
Does that exist anywhere? And it didn't. And so I just started talking to people about, well, what if it did? Wouldn't it look something like this? And by being loud and passionate about that, I just got extremely lucky. And I was talking with some colleagues at McKinsey about it. And then, like, fast forward 6 months, I get a call from one of them, and it's like, hey, I just got a, cold outreach LinkedIn message from this guy in Germany. He said he's made a bunch of money in the tech space and wants to invest in aging biology. And do I know anything about that? And obviously I don't, but I remembered a conversation with you 6 months ago over like some lobsters where you wouldn't shut up about aging biology. So do you want to talk with this guy? And he ended up being my co-founder at Apollo and provided the first capital to really create this company builder that
Wow.
helped launch my career. So like that, being loud and eventually getting lucky by making those connections, is what launched this for me.
So success is where luck meets loud, people. I think
Something
that's what
like that.
John Wooden said, something to that effect. So you partner up with this German gentleman who helps, write the first check, so to speak. And then what is the reality like? So that's got to be super exciting. But then you get to work. What was that
Yeah.
like?
So I think there were 3 times over the course of that first couple of years that I got hit in the face with a brick, that were big wake ups. The first one, so I was living in New York working at McKinsey, and I sold all of my possessions, moved to Germany with like 2 suitcases to try to build this thing over there. And the first piece was like, okay, well, here's some seed capital, but like now we need to go raise a fund. And like I had no idea what,
Like,
you know, yeah, how to be an entrepreneur, how to raise financing, or any of this kind of stuff. And so I had to, luckily, I had a decent network to pop up with my partner Niels and his group, and so that gave a grounding. But I had to learn quick how to fundraise, right? And it took way longer than I expected. It took more than a year to stand the fund up, because it was all like, well, who the fuck is this? Excuse me
right.
for swearing,
You
but
can say, yeah, you can say, yeah,
who the fuck is
you
this
can say
kid
that. Yeah.
who's never developed drugs before? That's like, at the time, a couple years out of grad school. And why is he the managing partner of this fund? And so, but we got through that because we had some interesting ideas. And then the second piece was like, okay, now you've got some interesting ideas, go start these companies. and I had to take the framework that I had for like, oh, well, I think this is how we would strategize, a
Mhm.
thing. And McKinsey and like management consulting in general, is famous for having a bunch of smart people come together and have a bunch of fun discussions and then hand over a PowerPoint and say, just do the stuff on the PowerPoint. Bye.
Bye.
And so for the first time in my life in the corporate world, I had to not just do the stuff in the PowerPoint. I had to make the PowerPoint and then say, okay, now I have to go put the stuff on the PowerPoint into practice. Um,
Uh-oh.
and that meant starting these companies, setting the strategy, all of this kind of stuff. So the way that this worked is we weren't just an investor, we were a company builder because these
Yeah.
companies didn't exist in the right way. So I would be either the executive chair or the CEO of the companies that we created under the firm, and had to figure out how to do every piece of the early sort of drug discovery cascade, which
Wow.
I made a ton of mistakes with early on, to be honest, in structuring the businesses, the sort of incentives and investment structures that I created, but then also in actually operationalizing the businesses. Um, but yes, but somehow it
Wow.
all kind of, one of the best things about entrepreneurship is there is some tolerance for mistakes, especially in the
Oh,
early
sure.
stage of a business.
It's expected. And I mean, those mistakes are learning opportunities. So I'm curious, what were some of the mistakes that created the biggest opportunities for you, or lessons learned, even?
So, I think the best lessons are in some ways the most specific ones. There are big lessons like, about hiring the right people, right?
Mm-hmm.
The big lessons are like really spending the time to understand what I'm good at and what I'm not good at, and then like spending the effort to go find someone who is really, really good at the stuff I've identified I'm not good at, and then bring them very close to me. Like that's probably the biggest sort of macro lesson of stuff that I made mistakes on early on. And the
Mm-hmm.
moment I started spending my time and effort doing that, things started getting a lot smoother. But when you ask the question, the things that I immediately think about are where I got batted in the face from underestimating the complexity of things. So like as a geneticist who did all these mouse experiments coming in, I came into the drug development world thinking, and with my background at McKinsey, I was like, okay, well, I've got the later stage. How do we do a clinical trial? Like, how does the strategy of a biotech company intersect with these, mouse experiments that we run? And are we running the right mouse experiments? And can we find the right drug? But then there's this big chunky middle, which is in fact where most of the people in pharma companies have spent their careers, of like, how do you know that that drug and not a drug with a slightly different atomic structure that like touches the same protein is the best one to move into humans? And then how do you build the right processes to manufacture that cheaply and efficiently and quickly, and like make sure that that project is moving forward? Like those two detailed pieces are such a core part of this business. And when I started the first actual drug development company that I had to run, like it felt like I had someone, and I just keep coming back to this now, like just throwing a brick, and it hit me right in the face because I'm like, oh God, I'm so bad at this. And I wasted so much time and momentum by not having either the skills myself or a partner in the company with me in order to do that well.
Mm-hmm.
Um, that's one of the biggest lessons that I took away. Like, it's sort of this, how big of an unknown you can have, especially when you're going into a space that is really, really new.
Yeah, and I think that also speaks to maturity, because I think most people, when they're trying to get investors or trying to accelerate something, want to have this air of I can do it all. And when there's actual lives on the line, or money, it's a whole different scenario. You really have to pinpoint, okay, I can't do this, and who do I need to help me get where we want to go? So you obviously launched Apollo, and that sounds really exciting, but that's not your full-time gig right now. In fact, you
In
have a very
fact,
nice shirt that
thank you.
says Cambrian. I hope people can buy similar ones online. Um,
We unfortunately do not have a merch store, so
well,
these are, yeah, unique to our team. You have to join the team in order to get one.
fair enough, fair enough. So, what was the transition process like? What's the
So
story there?
So I currently don't have a role within Apollo, although I'm very pleased to say that my partner Niels, who started it with me, they've gone on to actually do really well. All the companies that we started are still alive and moving forward towards the clinic with new
Nice.
drugs, and they have about 200 million, maybe a little bit more. 250 million AUM, something like this. So it's turned into a kind of nice, I
Sure.
think it's one of the larger funds in the world focused on aging and longevity, even today. Um, but about 4 years ago, made I kind of reached an interesting point, like another sort of like big lesson learned, which was related again to the specifics of the strategy about where my mission was taking me, right? I had kind of the gap that I had identified back when I was at McKinsey was about how no one who was in the aging biology science world was able to package their research and their kind of the potential of the discovery that they made and turn it into a real biotech strategy that could be attractive to VCs and pharma companies and so on. And so given that gap, what we created at Apollo was what I call the stepping stone indication strategy, that you might have something that could treat aging, but you're not going to go run an aging clinical trial in healthy people. You're going to
Hmm.
find a disease to move it forward, right? To test safety, efficacy, get it on the market, and then once you have all those things, you can start talking about prevention. And I know this is a little bit technical, but I think this is really the thing behind the why of the move. Um, and so when you're running a VC fund, we talked a little bit earlier about incentives, right?
Right.
The way a VC fund is set up, as you get some money from limited partners and you have 10 years to return that money to them. And if you're good, you're doing it in 3 to 5 years, right? And so the incentive for me when we created this kind of stepping stone strategy was to figure out how to get the science into this digestible, kind of more traditional biotech package and get liquidity around that package as quickly as possible. Right? That's the way the incentives of a VC fund structure are set up. And what I realized is that if we did that and we just like let these drugs go, our strategy was so good at just going for the early stage things that we would
Hmm.
never make it to prevention. We would never make it to the best and highest use of these discoveries, which would be, using them in healthy people to prevent disease. And in order to do that bigger, longer term mission, I needed to create a company with a different set of incentives, something that could hold on to these compounds and drive their development, not for 3 or 5 or even 10 years, but more like 15, 20, 25.
Hmm.
And so that's why I wanted to build not a venture firm, but I needed to build a pharmaceutical company focused on aging biology. And that's what Cambrian is. So we have kind of the same sort of playbook of how we bring scientific discoveries into Cambrian, how we, you know, drive those into the clinic for real biotech indications and so on. But instead of then, needing to push them out the door, we can instead
Hmm.
say, great, now we've succeeded at that. Now we have this really valuable thing, and now we're going to test it for prevention.
Nice. And so people out there who are just listening to this, James is actually 219 years old, but he looks amazing. So he knows longevity. Obviously, you have a company focused on longevity, but for listeners out there or people like me, what are some steps we can take, to extend our life or actually live a more healthy life in the time we have here?
Yeah. So the reality of the situation, as unfortunate as it is that the the amount that we know definitively about what benefits our, like you were saying, Matt, not just lifespan, but healthy lifespan, or
Mm-hmm.
as some people like to call it, health span,
Health, I like
um,
that.
right? The amount that we know about what interventions will increase health span is fairly limited when it comes to a lot of the new science that's emerged in the last 15 years. That is kind of why longevity is on so many people's minds.
Mm-hmm.
Really, the things that we have the best evidence for and that we know work are kind of the basic stuff. Getting, a good amount of exercise with a focus on zone 2 cardio, having a moderate diet with a focus on kind of like being a little bit more like a Mediterranean diet is kind of, I think, where the kind of ideal
Olive
is.
oil and veggies, right?
Exactly, right? Um, enough sleep. And like the fourth one, I think people forget sometimes is social connection and interaction. Like if you have those four things, you're more than 80% of you're like probably 95% of the things that we know definitively boost health span for people.
Wow.
And then the things beyond that are much more minimal, right? I think if you have high cholesterol, you should be on something to reduce cholesterol. If someone has diabetes, there are all sorts of diabetes drugs. The only kind of supplement type approach that I think has really strong data behind it is actually for omega-3 fatty acids, for fish oil to increase heart health. But other than that, it's all experimental. And somewhat depressingly, like we need to create products that then go through placebo-controlled, randomized clinical studies to see if they work or not, because the hard truth of medical science is that until we run these clinical trials, we don't have another better way of establishing if something works.
Yeah, and earlier in this interview, you talked about space and colonizing. I mean, I honestly think colonizing Mars might be less ambitious than drug development. Um, what in kind of broad strokes, James, can you share with our audience like the big steps that it takes to get a drug from kind of idea to market?
Yeah, so for a longevity drug, we actually break it up into 10 phases with like a big milestone between each thing. And I'm not going to do a full drug development course here, but like you start with an idea, which usually involves we would like to target this gene or this molecular process, and we have a way of determining whether we've successfully targeted that if you add in a special substance, right? You pour something in and did it change that target, right? So we call that target discovery. And then you have a compound, and now you have a compound, you call that a hit, and they have to optimize that hit, and you have a lead. And then when you do all of these experiments to see if it might work in humans, that lead progresses to a candidate. And then you do all of your toxicology and like figure out how long it lasts in your blood and so on. And then you go to phase 1, safety trials, phase 2, efficacy trials, phase 3, large efficacy trials in a specific disease indication. And now you've finally got a drug that can go on the market, and you can start your new phase 2 for prevention of age-related diseases, and then finally a new phase 3 for where you could get an approval for prevention in healthy people. And so that's 5 different clinical trials and 5 different preclinical giant milestones that are hard.
No
and
shit.
and luckily for us and for this field, like there's enough of an ecosystem in the biotech world, not in the aging biotech world, which is brand new, but in the biotech world for like those first 8 steps to understand and put some kind of benchmark of how valuable each of those things at each of those stages are. And that allows people to say, oh, well, that's worth about this many millions of dollars, risk discounted to the future. Therefore, we can actually put an investment in it today and fund the work to get to the next phase, which is now a little bit more valuable. And then you can fund the next work to get to the next stage, and so on and so on.
So I guess one of the benefits of extending lifespan is we'll hopefully see more drugs to market because it takes so long for this process. What do you think, call it the next generation, James, is a realistic, but call it optimistic lifespan? Like, could we see an average age in the 90s? What do you think?
So right now in the developed world, we're seeing an average lifespan of around 80, right? And an average health span, depending on how you measure it, in the early to mid 60s, I think is where people can reliably say, yeah, I'm in pretty good health around this time. And the goal is not just to move up the first number, it's to move up mostly the second number, a consequence of which will be to move maximum lifespan. And so from what we're seeing, just again, this is all context setting and hopefully
Yeah.
not too numerical, but to give you a sense of how hard it is to move these numbers. Today, about a quarter of all people who die of cancer. And so probably almost everyone listening to this, probably both you and me know someone in our family or close friends who have died of this disease, right? It's that common. And if we were to create a pill that eliminated cancer, any stage, nobody dies of cancer anymore, that 80 number would move to about 82.5 to 83. Right? So when you talk about increasing maximum lifespan from 80 to 90, you have to do 4 times better than a complete cure for cancer.
And that's like all cancers.
And it's all cancer.
It's
like
not the lung universal cancer. C. Yeah.
Yeah, exactly. The universal big capital C, no more cancer. You get that much. Right? And so in mice, what we can do today with a single intervention is up to about 30% of a mouse's lifespan. So if that mapped 1-to-1 with humans, we're talking about 24 extra years, right? So that's 80 to 105, give or take, 104. We don't expect that these things, especially a single intervention, will work as well in humans as they do in lab mice and so on. And so, but even like the point is, even if you did 1/10 of that, right? Even if you moved the first drug from 80 to 82.5, right? You're talking about an effect on human health that in some ways is the same quanta of impact as a complete cure for cancer. And we think that's really reasonable with the first generation of these drugs. And then we may even see better. We may see something more in like the 5 to 10 year sort of boost to both health and lifespan on average. And if we then start saying, okay, now you've fixed problem A, now let's work on problem B, which is now the thing that's really causing decline now that A is no longer an issue. Now we expect there will be, if not synergistic, at least additive benefits in some ways there. And so who knows what the upper limit is, but my prognostication is that once the first ones of these preventive medicines driven by discoveries in aging biology, once they come out, there's going to be an explosion, a race to try to find the next one and the next one and the next one. And running the really challenging clinical trials that we're doing are going to get easier and easier as we kind of standardize the system for evaluating these things. And we're going to end up with a story that looks a lot like what's happened with HIV from the 90s to today, where you start with a single mediocre drug that gives a person who, has a death sentence, which is something we all have, but on a longer scale than a HIV patient in the 90s, that gives a person with a death sentence a little bit longer, and then there's something new that gets added in, and now you have a second drug that goes into the cocktail, and now it's a little bit better. And then you create a better version of the first drug, and you get a little bit longer and a little bit longer. And I think that kind of improvements plus combinations sort of creating a cocktail will be such a driving incentive, especially in the second half of this century, of what the pharmaceutical and innovative healthcare world is going to be trying to do, that we're going to really be in sort of a sky's the limit territory. And I don't know if that means healthy life will move to 100 or above, but I think that that's not an unrealistic goal when we think about, if we use HIV as a historical example of what we've been able to accomplish, right? I don't think anyone in 1991 would expect that in 2023 we could say, oh yeah, HIV, it's a really nasty disease, but if you get it, you're going to live a normal life and it's not going to dramatically change your overall health. You just have to be careful about it and manage it.
That's so inspirational. I remember, I guess early 2000s, I was taking an HIV class at an undergrad, and it seemed like Magic Johnson was this outlier, and we're all kind of waiting, when is it really going to kick in for him? And I remember the professor saying he has access to the greatest doctors, blah blah blah, and it was kind of depressing. It was AZT was the big drug, but it really didn't seem like there was that much hope. But then fast forward 20 years, which is not that long, and it's everyone is, I don't say everyone, but Magic Johnson's outcome is now pretty common.
Yeah, it's the rule instead of the
it's the
exception.
rules, and it's because of people like you or people, prior generations where they took these chances and it was 1 in a billion, and now real like improvements have been made. So I mean, I'm so glad they're not only just you, but people like you focusing your intelligence and time and resources to approving things for jackasses like me and other folks out there. I'd love to have you back because I could talk to you for hours, but I'm curious, James, what professionally, what are you most proud of?
Cambrian is now a relatively large company. We've raised something like $200 million. We've got 15 different drugs in different stages of development. And about a year ago, I realized that there are more than 100 people who, one way or another, are devoting at least this chapter of their lives to this idea of building drugs that target the biology of aging. And the vast, vast majority of those people are not diehard aging biology nerds like I was or am. And every time I think about that, the gratitude that I feel for these extremely talented people who have taken all of the dreams that they could go chase and like attach themselves to this crazy idea that I've helped bring forward and kind of are shaping that and making it more and more real. Like, it is the most amazing and humbling thing that I have ever experienced, and working within a team, and it's like, oh yeah, I don't know anything about that aging stuff, but like, here, let me inject how I would do this to develop a drug if I actually wanted to make it succeed. And I don't know, like, I feel so much pride running this organization every day by the compliment that all of these fascinating people have paid to me and to this mission by saying, yes, we're going to align ourselves with that. And this is now a thing that we believe in and want to bring to life, to reality. That's definitely the thing I'm most proud of.
You've created a longevity army, James.
I don't know about that.
But, where can, I mean, I'm inspired, and I'm sure your message is going to resonate with, the hundreds of millions of people tuning into this. I can be optimistic. Where can these folks learn more about Cambrian, what you're up to? So where can we send them?
Yeah, I'm not a big social media person, but I think you can find us, and we talk a fair bit about the company on LinkedIn is probably the best place to look for me and Cambrian. And then you can also read more about the company on our website, which is just cambrianbio.com.
And I'll have links in the description of this episode. So James Peyer, thank you so much for joining us today. Really appreciate it.
Matt, thanks for having me. This is a really fun conversation.
Thank you for listening to this episode of the Matt Balaker podcast. To learn more, please check out mattbalaker.com and encourage your friends to like, subscribe, and share. Really appreciate it.